Welcome to February 21st LeetCode Challenge, Majority Element. Given an array of nums of size n, return the majority element. The majority element is the element that appears more than the lower bound of n over 2 times. You may assume that the majority element always exists in the array. So given that you have the numbers here, array, you have 3, 2, 3, what number appears the most amount of time, which would be number 3, therefore return the majority element, which is 3. Given this, and then look at this example, number 2 here, we have, say we have this array here, the number that appears the most time will be 2. So it's pretty straightforward, return the majority element. So the tricky part is being able to solve this in linear time and constant space complexity. And we have experience where n is equal to the number of length, and n is between 1 to 5 times 10 to the 4. And here's our index at nums I. Alright, so this one we want to, there's a couple ways of doing it. The first way is to create a set or hash map. Let's call it a hash, or just call it map, I guess. Oh, that doesn't work. Let's call it num hash, and then we get a hash map, which is going to be a set. So for each nums in numbers or nums, we are going to put the number in the hash, so num hash, and we put that in nums index. And then that's going to be the num hash dot get. And what we want to get is the num at index at location 0, or get plus 1 because we want to move 1 to the right in the hash map. And then so if the num at hash at location num or index num is equal to the length of nums. So we want to basically, if we put the number inside our hash map, we want to find if it's equal to more than the lower bound of n divided by 2. So what we're going to do here is going to find the length of the nums, divide that by 2 using using integer division plus 1. And we're going to basically return the number if it exists, if this condition is true. So that's pretty much it. Return num. So basically put all the numbers into a hash map, and then every time we put it in, we increment it by 1 as the value. Then if we find that the index key is greater than half of the number of the array, then we just return it. Let's run this. Submit it. Okay, yeah, that works. Time complexity is big O of n, where n is the length of nums. The space complexity is big O of n as well, because the hash map itself is one element is frequency higher than n divided by 2. So at worst, we will have big O for space complexity, big O of n divided by 2 plus 1 keys, which is going to be the space complexity. Alright, can we do this? Let's see. So they want, I guess, linear time and also constant space. This is not constant space, it's big O of linear time for memory, for space I should say. So could we do a little bit better? The answer is probably yes. So what we're going to use is called the Boyer-Moore majority vote algorithm. So what we're going to use is that. Here, how that works is it's now going to find the majority of a sequence of an element using linear time and constant space. Ta-da, linear time and constant space. It's named after Robert Boyer and Moore in 1981. And it's pretty much just the streaming algorithm. So here's how it works. So the first thing you want to do is assign So it's a majority vote type algorithm. So you will basically every time you hit a number that it's or recognize, you just increase the vote for it. So you'll need a vote and a majority number to keep track of. So the first thing you want to do is vote is equal to none, 0, and majority is equal to none. There is a way to improve it, so this is not the case where you don't have a majority, but it's ensured in the it's ensured right here that you may always assume the majority elements always exist, so this is not going to be an issue. But just to let you know, so same deal. So for num, let's call it n this time, in nums, if the vote is equal to 0, then we want to basically assign majority of equal to n. Assign majority to n. And then what we want to do is actually close up one line. And for right here, we want to update vote or increment it by each time if the following is true. So I'm going to use the ternary operator here. So it's going to be 1 if increment by 1 if the majority vote, I should say, or majority is equal to n, else decrement by 1. That's pretty much it. Return majority. So let's keep in contact with the Boyer-Moore majority vote type algorithm. Alright, let's give this a run. So as stated, this solution should be, majority, should be linear time and constant space. Submit it, and it should be a little bit higher here in terms of, no it's not. Alright, that's it, the majority vote algorithm. And there you go. Have a great day, guys.